Alright, we're going to go over first and second derivatives. Alright, first and second derivatives. Alright, now we're going to use this function here, f of x. I don't know if y'all can even see this marker.
It's very hard to see.
Oh, sorry. 200 plus 8x cubed plus x to the fourth. Alright, that's the function we're going to use. And the reason we're going to do this is the first derivative tells you if the slope is negative or positive. The second derivative tells you the concavity of the slope. And that's, you know, whether it's like this, like that, or like this. Those are the four concavities you can have. Now, we are going to take the first derivative of this function. And I'm going to switch it around so we have 4x squared plus 24x squared. Yeah, cubed and squared. And we're going to find, we can take out 4x squared, and we're left with 6 plus x. And we have to find the critical values for this function. Well, for this is 0, we know, and 6 plus what gives you 0? Negative 6. So we know that this is the critical values for this function. Alright, 0, negative 6. So we're going to write them over here. Negative 6, 0. And then we're going to take the second derivative. Now, taking the second derivative is just taking the derivative of the first derivative. This is the first derivative. So we're going to take the derivative of that, which is 12x squared plus 48x. We can take out a 12x, and we're left with x plus 4. And again, we're just going to find the critical values when this is 0, and that of course is 0, and negative 4 plus 4 is 0. So we're going to get some CVs of 0 and 4. Now the only new one we have is negative 4. We don't need to put the 0 down again because we already have that. Now we're going to make these into a table. And we're going to do f prime of x over here and f double prime of x over here. Now this will be able to tell us if f prime of x is positive before negative 6, in between negative 6 and negative 4, in between negative 4 and 0, and after 0. And also the same with f double prime. Now, I've already calculated these, so we're gonna use a number less than negative 6, so we're gonna use negative 7. I already calculated these, and we get negative 196 for that. We're gonna use negative 5 here. Get negative 100 there. And remember, all we care about is if it's negative, which both of these are. And after that, we get positive numbers for that. So that's just saying that it's decreasing until it hits negative 4, then it's increasing and increasing. Now, we're going to do the same thing with the, use negative 1 and 1 on the opposite sides of 0. Now we're going to do the same thing with the second derivative. Now, and I've already calculated these two, and that gives us plus plus negative plus. Now, we know that at negative 7, this function is, the slope is negative and the concavity is positive. So, you have a positive concavity, it looks like that. Now, we only want the negative side of it. So, our function looks like that there. And at negative 5, that's the same effect. It's negative slope with a positive concavity. So it looks like that again. Now this one is positive with a negative concavity. Negative concavity looks like that. We only want the positive side of it. So we get that. And these are both positive. So we have, again, the positive concavity with an increasing slope. So we get that. Now, if we were to sketch this graph out, we could use these to show us, before this point it's doing that, and after this point it's doing that, and then, it's doing something like that, and then it's doing that. That's a rough guesstimate of what the function would end up looking like.